Hi guys, so today we're going to be discussing Leetcode question 268, missing numbers. So the question is, given an array nums containing n distinct numbers in the range 0 to n, both inclusive, return the only number in the range that is missing from the array. So how can we go about this? So the first approach is using a count sort algorithm. So how does this algorithm work? Let's understand with an example. So let's say we have a nums array which is of six elements 0, 1, 2, 3, 4, 5, and the values are 3, 0, 1, 2, 6, 4. So how does the count sort work? It iterates to every element of the nums array and creates a different array in which for every array value it goes to that index in the new, let's say, a count sort array and increments its value there by 1. So how would it go about? So since in this case n equals to 6, so we create a count sort array of length of, let's say, n dash length 6 plus 1. So the indexes would be 0, 1, 2, 3, 4, 5 and 6. Initially all the values are 0. So now what happens is we start iterating the nums array. For the first value 3 of the nums array at index 0, we go to the index 3 of count sort array and increment its value by 1. Similarly, for the next element of nums array 0, we go to the index 0 of count sort array and increment its value by 1. For value 1 at index 2 in nums array, we go to the corresponding index in count sort array and increment its value by 1. For value 2 in nums array at index 3, we go to index 2, which is this, and increment its value by 1. We keep proceeding like this, and this is finally what we have. Notice that since we have not encountered 5 in the nums array, so therefore its value is always 0. So now after running the count sort algorithm, if we iterate to this count sort array and see where value is 0, that means we haven't encountered that element and that is our missing element. So what would be the algorithm for this approach? So first we have to create the count sort array. So how are we going to do that? So let's say for int I is equals to 0, I is less than n, I plus plus. This is to create count sort array. So what we're going to do now, let's say we get the value is equals to nums I, and this value now becomes our new index. So index for count sort is equals to value. We have an array count sort which we created of length n plus 1. So we go to the new index, count index for count sort, and whatever the value is there, we increment that by 1. So this is to create the count sort, and after that what we do is find missing value. And how do we do that? So for, let's say, we just have to iterate the new count sort array less than equal to n. We just have to iterate the new count sort array, and wherever the value is 0, count sort I is equals to 0. That means that element is missing and we return that element. So this gives us our answer. So this is one approach to go solve using count sort algorithm. You create the count sort array and then for every element you check if its value is still 0. If it's 0, that means we haven't encountered that element, and that is our answer. The other approach is, before moving forward, the time complexity in this case of this count sort algorithm, since we have to iterate over the array once and create an array of another array of length n plus 1, so the time complexity is O of n, and since we are creating another array, so the space complexity is also O of n. Now can we do anything better than this? Can we make this approach even better? So for that we use another algorithm, which is sum of consecutive and natural numbers. So it's a mathematic property. So the property is actually something like this. If there are, let's say, n consecutive numbers, 1 plus 2 plus 3, and we have to make a addition of them, let's say till n being some random integer, positive integer, so the sum of this would be n into n plus 1 by 2. This would give us the sum of n consecutive natural numbers. So let's take an example for this. If we have 1 plus 2 plus 3 plus 4 plus 5 plus 6, we can also add 0. It does make no difference because anything plus 0 is the same thing. Sorry. So what would this be? 1 plus 2 is 3. 1 plus 2 is 3, 6, 10, 15 and 21. So this gives us 21. Now let's verify this exact same thing from the formula. What was the formula? N into n plus 1 with n into n plus 1 by 2, where n is 6. So 6 into 6 plus 1 by 2. This gives us 6 into 7 by 2. 6 into 7, 42. 42 by 2, 21. So these values match. Now proceeding to our case, where again nums equals to, this is the array that we had, right? 3, 0, 1, 2, 6, 4. And the missing element is 5. So this is index 0, 1, 2, 3, 4, 5. So now we calculate the sum of all these elements. So this is 3, this is 0, 1, 2, 6 and 4, and we add all these up. So what is the sum that we get? 3 plus 0, 3, 4, 5, 6, 6 plus 6, 12, and 12 plus 4, 16. So this is the sum that we get of all the numbers that we have in our nums array. If we're calculating the sum of 6 numbers, 6 numbers from 0, 1, 2 till 6, according to the property studied, what should be the sum of that? n into n plus 1, right, divided by 2. So what would be the sum in this case? As we had just discussed, 6 into 6 plus 1 divided by 2, which is 21. So this is the actual sum, that the sum it should have sum up to. So the missing element would then be, missing value would then be whatever the actual sum should have been and what our current sum is. So this will give us our answer. Let's verify this. So actual sum in this case of 6 consecutive natural numbers is 21, as we calculated here. And what is the sum that we have in our nums array? That is 16, right? Up here we've calculated. What is the difference? 5. So this is our answer, since this is the missing element that we had. So what would be the approach for this? How would we write the algorithm for this? So coming to the algorithm, so initialize a sum variable 0 and then create a loop for, let's say, int I is equals to 0, I is less than n, I plus plus, incrementing every index value. You just calculate the sum of all the numbers in the array, which can be done using just this one line, nums is equals to num plus I. So now we have calculated the sum. At the end of this loop, we'll have the sum of all the elements in our array, in our given array. What is the actual sum of the element that it should be? So this is just the pseudo code. So actual sum should be n into n plus 1 by 2, right? So this should be the actual sum. And what is the missing value then? Missing value would be whatever is the difference between actual sum minus sum, and then we return this value, return missing value. So this is our answer. So let's analyze the complexity of this approach. So the time complexity of this approach, since we're only iterating over the array once, calculating all the sum of the elements and just returning the missing value in just one computation, that is O of 1. So the time complexity of the algorithm is O of n. And what is the space complexity? Notice that we're not utilizing any extra space, we're just using one variable, missing value, and actual sum. So that is essentially a space complexity of O of 1. So this is our answer. I'll attach the link to the GitHub code, to my GitHub repository for the code for this question below in the video. Thank you guys for watching. Keep coding, and I hope this video helps in solving your doubts. Have a great day.